Hello, and welcome to Mitsubishi Electric webinars. My name is John Harity, and I work within the marketing group here at MEAU. The following Application Solutions webinar will cover vertical form, fill, and seal applications in the packaging industry, where we will take a look at how Mitsubishi Electric's factory automation products can be used to create a powerful solution. It is our goal here at Mitsubishi Electric to provide automation solutions for the packaging industry that reduce design costs, reduce the total cost of ownership, and increase overall equipment effectiveness. These goals are obtained through providing robust, high-performance equipment that help to get the job done right. The vertical form, fill, and seal application solution comes complete with instructions on how to get your machine set up and running quickly. The standalone motion controller with a built-in PLC provides superior servo performance and machine sequence control, all within one controller. The iQ platform's instruction execution times and memory performance provide advantages for continuous motion and intermittent motion applications. The VFD can be controlled directly from the HMI using a dedicated communication protocol. This reduces wiring costs and labor costs and provides an option to monitor the machine remotely if desired. Each of the three servos in this application are controlled with servo motors on a fiber optic servo network known as SSCnet 3. Through reduced wiring setup and installation simplification, up to 20% can be saved in wiring costs. The 0.44 millisecond refresh rate for the servo network allows for very accurate control of the servos. Here we have the layout of a typical vertical form, fill, and seal application. First, the product enters the machine through the feeder at the top. The bag material is pulled by the servos to be released from the roll stock. A funnel hood helps to shape each bag, and shortly afterward is a thermal heat sealer to vertically seal the bag material as it moves downward. Vertical film index drives move the material downward based on the operation cycle set by the operator. Each bag is then cut and sealed to be carried away by the unloading conveyor. You'll notice several other components as well, including a stand for the GOT and optional sensors for safety, for counting the product, registering each mark on the material, and for low roll detection. Example applications in this case include industrial powder filling machines, machines for pouch packaging, and also those for filling with various foods and beverages. The diagram to the right illustrates how each one of the Mitsubishi components is arranged to communicate with the vertical form, fill, and seal machine. To the right side of the machine, you have three servo motors, one for sealing the bag shut and two for simultaneously indexing the web material. These are controlled with a Q170 MCPU standalone motion controller using the Servo System Controller Network, SSCnet 3. Constant heat is applied to seal the bag material shut with the Q64 TCTT temperature controller. An E700 VFD controls the speed of the exit belt to carry the product away. Lastly, we have a GT1685 12.1-inch display touch panel for the operator to communicate with the machine. Before the machine can begin operating, the user must input its initial parameter settings into the PLC. To change the default values for machine startup, the following structured text program can be modified using Mitsubishi Electric's GXWorks 2 software. The program initializes settings and allows for the settings to be changed whenever the operator modifies them from the touch panel. Now, let's look at the machine's operation sequence. First, as soon as the machine is turned on, the motion controller automatically performs a digital homing sequence for the vertical index roller axes and ensures that the sealer axis is in the correct position. Next, the machine enters what's known as virtual mode. This mode not only provides additional flexibility to the programmer, but it also simultaneously controls both of the vertical index roller axes through the use of an electronic drive shaft. Next, the machine enters its motion control sequence, where the servo movement waits for an indexing control signal from the PLC before starting. The index rollers move forward for the length of the bag, and then the sealer axis moves to cut and seal the bag. This motion control sequence repeats until the operator stops the machine or until the low roll detection sensor turns on. As the bag passes over the funnel hood, it is formed into a tubular shape. Just after the bag begins to take shape, heat is applied evenly to seal the side of the bag. The Q64 TCTT temperature controller is connected within an extension rack to the standalone motion controller in order to modulate the temperature and maintain constant heat. Here you can see two communication channels being configured within the parameter settings of the PLC to maintain the heat. The first channel represents the vertical thermal heat sealer.